Excellent. You guys hear me pretty well?
Yep.
Yeah. All right, so this is the last one just before lunch. So if I finish early, that means I'm a hero, right? So I just kind of keep it quick and light. It's not going to be nearly as in-depth or meaty as the previous two guys. It's more just kind of introducing the concept that I thought was cool. It's actually one of the core things that helps the network, the internet, everything we're familiar with work, thrive, and maybe you can even use it a little bit in your own network. So it's IPv4 Anycast. So the quick and dirty, who am I? I have a lot of little letters. I'm sure you guys have a lot of those little letters. I'm an engineering director for a data center group, so we do multiple co-location facilities, tier 4 design, all that good stuff. We kind of guarantee your uptime sort of thing. In and around Texas, also do some of the special technology installs for the Memphis Grizzlies NBA team. And I'll be happy to talk to you guys about any of these things we're talking about in the future. I also do consulting too, when I have this tiny free time in between the 5 minutes I eat dinner and see my kids. So moving beyond that, one thing I'm really proud of, it's a community we've started developing called the Brothers List. So you got myself right there. Andrew Cox is out of Australia, so he wasn't here. Justin is right there. You got JJ right there. Andrew Thrift is actually out of
New Zealand.
New Zealand, that's right. He's a Kiwi. And then Tom, so believe it or not, the only one I didn't have to Photoshop his picture of.
That was taken last night, right?
Let's not forget Mike Hammond, who's the consummate butt of every joke, who doesn't happen to be here, so I'll continue to make jokes about him. But kind of going back to this, it's community guys focused on doing the same kind of things you do, right? We do a lot of different technology stuff, a lot of guys from a lot of areas, all of them smarter than me, by the way. And one thing I like to say about it is that we're all very passionate about what we do, right? This isn't just what puts food on the table, it's actually what kind of gets us going, right? So we get fired up, and sometimes we'll misquote people, and that's unfortunate, and we don't mean to, or sometimes we'll give our opinion and beat it to death. But just take it for what it is. It's a good time. We try and introduce new people every now and then. And yeah, for sure. You know, just to get a different perspective, you know, people from different industries doing all kinds of things. I think it's pretty cool. And at some point, maybe one day, we'll be able to have an actual MikroTik guy on there. I seriously doubt they're allowed, but you never know. So, back to the presentation. IPv4 Anycast, right? So there's really 4 different types of addressing. You have unicast, which is one-to-one, so that's me to one of their hosts, right? You have multicast, which is one to unique many, as in I want to subscribe to this address, anything sent to that, you know, I'll grab it and listen to it. Multiple people can subscribe to it. Once the end broadcast I send out, it goes to everybody who happens to be listening at once. And then you have Anycast, which is many potential receivers, right, all listening at once. And so here's the official definition off of Wikipedia, and it's horrible, and I just wanted to read it to you. It's not horrible, you just have to really break it down. But Anycast is a network addressing and routing methodology in which datagrams from a single sender are routed to the topological nearest node in a group of potential receivers, though it may be sent to several nodes, all identified by the same destination address. That was one sentence, by the way. So when you break it down, what does that really mean, right? It means I'm Bob, right? So all these guys are Bob, all the blue dots are Bob. Here's somebody who's a green dot, and they are looking for Bob, and they say, where's Bob? All these Bobs respond. Whoever Bob happens to be the closest, that's the one you go to, right? So think of Bob as a public IP, right? He's actually advertised from multiple locations, and you just happen to go to whichever one happens to be closest, even though they're all the same. We'll kind of get into how that works here shortly. So when is it used? Content delivery networks have been using it 20 years in the internet. Content delivering like Cloudflare, or somebody was it Tom mentioned Akami. So they take your website, they cache it, and they throw it into a bunch of different locations and accessible from all over the world. Right? The core of the DNS structure uses Anycast addressing. So and we'll actually talk about it. It's really anything you want available from multiple locations, usually geographically dispersed too. So a good use case is Google's DNS. So when you go to 8.8.8.8, does it always go to the exact same server? No, it doesn't. So if you look, the scan here on the left, or the trace route that's coming from just somewhere in Texas, right? And you see it has multiple hops, ends in a 216, 239, subnet just before it gets there. Well, if you go from Australia, you see the last hop is completely different subnet, right? So that's something that's actually available from Australia. So it doesn't come all the way to the States to hit that server. It hits a local Anycast address. So they advertise that same address in multiple places here in the States, all over. They also advertise it all over Europe, all different countries. You see I added Singapore there as well, so they've got their own node. So they basically announce that same address from all different parts of the world. You just go to whoever happens to be closest, right? So kind of seeing how that works kind of on a small scale. Here's our basic demonstration. You've got 4 routers. 1, 2, 3, 4, all there in a row. You've got 2 servers, group A and group B, top and bottom there. And those guys are advertising themselves as the exact same address, right? So this client wants to get to gregsowell.com. He does a DNS lookup, resolves to 001. So then he passes that to his default gateway. His default gateway says, what does my route table look like for this, right? Pretty simple. This is a very simplified version. So the lower route goes through 2 routers, right? So he's got a distance of 2. The upper route has 1 route, so it's shorter. So he takes the least path, I guess, in this case, right? So it's kind of the quicker hop. So what happens if that top, most preferred route breaks? He just reroutes to the secondary one, right? So it actually gives you a little bit of resiliency as well. So something to just kind of think about that might be interesting is what is that router out there, what is his perspective of the network? From the vision of his route table, this is what he thinks it looks like. Right? It looks like one big network. He doesn't see it as 2 individual nodes. He thinks it's just one node that's reachable from multiple locations, which I thought was kind of interesting.
Does that take into account weighted metrics on the router? So top 01 is like 100 cost, it was 50 cost on the lower 2.
Right. This is just a super simplified version. We'll look at kind of how OSPF and things like that actually take into account. And you can wait, and so as the gentleman said, you can do different things, affect different metrics to actually affect the flow. So you can prefer one path over the other. You can do a lot of different engineering things. But just kind of as a basic to lead into everything. So Anycast clusters, you have local clusters, global clusters, or global networks of local clusters. We'll take some looks, some pictures. I had to add lots of pictures because this is way too fast. Cluster of servers may share a common virtual interface. It's a really long way of saying you can have loopbacks that have that Anycast address, that 001, and they can advertise that out. You can use an IGP to get that out of the servers. A lot of times nowadays, though, people will, in lieu of kind of doing it all manually, they'll do load balancers in front of their servers to kind of do all that heavy lifting, all the doling out of the connections to all the servers behind them, or even clusters of load balance servers. So a local cluster, multiple servers, heading into a router that all say that they are the exact same IP address, or it could be instead of a router, it could be a load balancer. And in fact, I guess is really more or less an intelligent load balancer, or an intelligent router. So here's a global cluster. So you've got clusters. Top one happens to be in New York, bottom one happens to be in Dallas. They advertise via BGP, which Tom talked about ad nauseum this morning, which actually was a great presentation. You should all watch it if you haven't seen it, for people that happen to be watching this recording. So they just advertise it on the internet. And then what's global network with clusters? You got local clusters in New York and Dallas, right? Pretty simple concept. So a use case for the WISP, what does it mean to you guys? I mean, it's interesting in theory to know that all that stuff works, but how can we actually use it? So in my mind, how did you use it for speed test servers in your network? So if you're geographically separated, say these are 2 different locations. So ISP1 sits in, I'm going to keep referencing Dallas, because that's where I'm from Texas. So I'm going to say Dallas and Houston. So ISP1 is in Dallas, your secondary ISP is in Houston, and you have a network that's all interconnected, right? So you want your clients to go to the geographically closest speed test server, right? Which is generally where they're going to exit the internet as well. So in this case, the client should, by default, head out up here to ISP1. As you see, speed test A, 001 is what he's advertising as his address. Speed test B is advertising 001 as well, so those routes are injected in. And let's see, we've got a little video, because I would never do anything live learn my lesson, but that's just insane. So basically, we have a tracer out of the ping. We start the ping to 001, right? So you can see that it's up and operating. And then over here, yeah, that's me explaining that it's taking that path. So we do a trace route. You can see it routes to router 2, router 1, that hits speed test server. Pretty simple. So then we're going to go into this router. We're going to disable the interface that happens to connect over there. You'll see a little bit of ICMP drop. You'll see OSPF reroute. So it's all one big area. It's super simplified. Do another trace route. You see it go to 2, 3, 4, 5, and hit speed test server. So it's a suboptimal route, I guess in theory. But if there's a break in your network, it reconverges and you're still accessible, right? And then we bring the link back up. We give ICMP a second. You kind of see it flicker a little bit, and then you see the trace route go back in the wrong direction. So in the previous slide, yeah, if you get a break in your network, it'll lose that Anycast address coming from the other locations, and it'll just kind of reroute back around, which I think is kind of an interesting use. So speed test servers, if you go to speedtest.net/mini, I think they have a version of their speed test server that's free. All you need is a web server running PHP, throw it in there, and you get this kind of cute little interface. Also, if you can encourage users to use speed test servers within your network, the internet speed is always going to look far superior than it will if they're going through your internet links, right? So, and it's also, I mean, it's a good testing directory. You can also do this with a MikroTik. If you're doing a speed test to a specific MikroTik, you can do the same sort of concept. This is what my beautiful lab looked like. I always think it's hilarious. You know, when you have these nice polished slides, and then it's just me with like a bunch of routers stacked up and Aunt Jemima sitting right behind it. You know, it's pancakes there. I don't know. I always like to see behind the curtain. So some of the gotchas, right? Some of the caveats that you might run into. So in the big bad internet, multiple DNS server clusters, right? So if you have 8888 as a cluster, you also want 88844 as a secondary cluster. Right? Cluster on a cluster, that way if the primary fails, kind of can't go over to secondary. It seems pretty logical. Long-lived TCP-based sessions. So if I'm doing a FTP download from an Anycast server, and it takes 5 hours, and for some reason the internet reroutes me to a different Anycast server, that connection's going to fail, right? Because I completely switched over to a whole different place. That's something you have to think about. Some HTTP servers you can do, instead of doing like session-oriented stuff, you do cookie-based stuff, so that if you do switch to a different server, you'll still be solid. Or if you're doing Anycast address off a loopback, the server can actually pass back his actual defined interface IP address, so you'll go just to that one server from then on, which is kind of cool. Identifying troublesome servers, so if you've got one server in the lot that's causing problems, it can be kind of tough to troubleshoot sometimes, tough to track down. Then a lot of external metrics, so you're doing a lot of monitoring, you're keeping stats on all of your servers, which of course all of you guys always do, right? All of your servers and routers and trending information over time and doing baselines. You should look at CAC after that. It's a great product for that. Maybe a little cumbersome, not exactly pretty, but it's really great. And then again, Tom's poor man's NetFlow torch. You know, you can figure out which server it's going to based on the customer IP. And then a possible security bonus, which actually kind of ties into what Tom was talking about, is DOS protection. So if you are getting a DOS attack and they happen to be located in Dallas, right, or somewhere near there, and you have one of your Anycast servers, their attack is just going to go to that server. So all these other regional nodes you have, all those other customers are protected from it, right? So if you lose 25% of your infrastructure, it's better than losing 100%, right, in my mind. Also, if it's a distributed denial of service, which is something else you talked about, it's coming from multiple zombies from all over. Instead of having a 1 gig attack on a single node, say you split that amongst 4 or 5 regionally based nodes, so they'll just go to whoever happens to be closest, and then now it's, instead of a full gig attack, it's 250 megs, and you might be able to sustain that. Hopefully you can, right? So it kind of gives you, it's, I don't think people generally design exactly for protection, but it's sort of an added bonus-ish sort of thing. One last thing in that is, come and say hi to me. I've already met a lot of you guys, but that's a big part of why we come here. Because we do so many things. I think, like IT guys, are like the Swiss Army knife, right? With the Leatherman of employees. We do a little bit of everything. I think MikroTik is very much in that lane. It does a little bit of everything, right? So sometimes we do some incredible things we shouldn't or shouldn't be able to do, or maybe shouldn't do just at all. And we're always glad to brag about that stuff. You always learn something. So thanks, and do we have any questions? Yeah. What's up?
Okay, I have a question about the Anycast. Whenever you say generate that traffic and it hits that router, does that router then generate that traffic on both exiting interfaces?
So like, let's pull back to that. I'm a very visual person. So which route are we talking about?
Go
Like,
back
in
a
this-
couple more slides. It'll be easy. Some more. It was like your first slide, I think. It was the simple, that one. Okay,
Okay.
so let's say the computer on the side generates the request to 001. Does the traffic pass via 168.0.1 and 168.0.2?
No, it's like in this case, it's not ECMP, it's not equal cost, right? The two paths aren't equal, so it's actually going to prefer one over the other. So it'll pick this one and go. If you were going to run into an equal cost path, see, since there's only 4 routers, even if you hung off of this would be a shorter path, right? So it's always kind of preferred. It's going to pick one or the other. If there was an opportunity where this was even, if there was another router here, you'd have to do probably some kind of manipulation just to be safe. So when you inject this route, you'd want to adjust the cost so it's slightly higher, right? Or something to that effect, just to kind of protect yourself. That was interesting. It's a good question.
Are you suggesting equal cost duplicates packets though?
No, if you get an equal cost path, it's going to be unpredictable on where your traffic's going to be. Because generally with ECMP, it'll load balance for a little while. Well, it'll pick a direction. I think ECMP will reroute every 10 minutes. Like the Linux kernel will redo its hash, or at least in the implementation we're using MikroTik, it'll like rehash, and it could theoretically pick a different path. So you could be good for 10 minutes, and then it could just completely, and then go a different direction. And so, and if you're just doing a speed test, that's kind of one of those who cares sort of things, but it could be important depending on what you're doing. If it really is a service that you want to stay up and on, or you want predictable results, you always want to know that this person is going here unless there is a failure, just for stuff like that. And I'm extremely anal when it comes to those kind of things, so I always want to know where it's going. Helps out. Any other questions? It's pretty simple talk. I didn't figure I'd get to it.
I came in for 11:30 and you're already done.
It's lunchtime. I can't.
You're not going to stop Greg getting his lunch.
So I missed it all.
That's why they recorded. Well, I guess we're done. I guess that's it.